All right, hey, this is Unit 2, Topic 2, Lesson 1 of Algebra, and we're going to be exploring arithmetic and geometric sequences. So today's warm-up first is about evaluating expressions. We got 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27, and 3 to the fourth power is 81, because to the power just means that's how many times it's multiplied by itself. And you're noticing here that there is a geometric sequence, which means that it's being multiplied by a common ratio, the same number over and over again. Same thing goes down for here, substitution with function notation. So we got function notation, f of x is equal to 2 to the x power. And we're going to substitute by finding f of 1, f of 2, and f of 3. If we put 1 in for x and solve, you get 2. And if you put f of 2 in, you get 4. And if you put f of 3 in for x, you're going to get 8. And once again, you got a geometric sequence there. So same thing over here is the exact same answers as above. So we've got 3, 9, and 27. All right, so that starts us off talking about our sequences. Geometric sequences to be exact, but we're going to start off with an arithmetic sequence. So this is growing dots. Describe the pattern that you see in the sequence above, figures above. So we notice that there's 1 dot here, then there's 5 dots, and then there are 9 dots. So what you should notice is that it's plus 4, plus 4. So this is an arithmetic sequence. It has what we call a common difference. A common difference just means it's being added by the same amount each time, which is going to make a linear equation. Describe the pattern you see, as I just said. Assuming the sequence continues in the same way, how many dots are going to be after 3 minutes? Well, if you add 4 again, you're going to have 13 dots. After discussing several patterns, so how many dots are there after 100 minutes? So this is where you're going to want to find an explicit equation. An explicit equation is an equation that can help you find any amount of numbers. So in this case, if I'm going to use function notation, I would say f of n, or y equals, I'm going to use function notation here though, f of n is equal to, well, the pattern is 4 times n, and then plus the starting point. And the starting point in this case, well, if this is at the beginning, it would be plus 1. And what you're going to notice about this is that it always works. 4 times 0 is 0, plus 1 is 1. 4 times 1 is, if n was 1, 4 times 1 is 4, plus 1 is 5. So that's going to work no matter what. So if I put 100 in for n, 4 times 100 is 400. 400 plus 1 makes 401. How many dots after t minutes? Well, so that would be, basically I've already done this, so f of t is equal to 4 times t plus 1. All right, so that's an arithmetic sequence, common difference. This is going to have a common ratio. The difference is basically that a ratio means it's multiplying, a geometric sequence, and a common difference means it's adding. 3 dots, and then we've got 6 dots, then we've got 12 dots, then 24, and then 48. Now, no, I'm not counting them, even though it is good of you to notice that there are 3 different groups here, and each group is going to be doubling each time. All right, so it goes from 1 dot in each group to 2 to 4 to the 8 to 16 dots. And what you're going to notice is that the numbers are also just doubling. So the pattern is times 2. All right, so let's use that information to answer some questions. Describe the pattern change you see in the figure. I just said that. Assuming the sequence continues the same way. After 5 dots, so that would be 96 because you just multiply 48 times 2. Write a recursive formula to describe that. Okay, recursive formula. First time we've seen this. So f of 1 was, I forgot how many dots, 6. There were 6 dots in the first minute. Not the 0th minute, the first minute. There's a difference. So f of n, I'm going to use subset notation. I know that n was a little too big, is equal to f sub n minus 1. And then it was multiplied by 2. So that's the starting point. It was the first minute, and this is the rule. So if you want to find any number, so let's say you want to find the 50th number, you would just take the 49th number and multiply it by 2, because that really is just the pattern. So if I want to find the 6th number, if I said n was 6, f of 6, f sub 6 is 96. Or was that f sub 5? Oh yeah, that was f sub 5. So f sub 6 is equal to f sub 5, which is 1 less than 6, multiplied by 2. So there you have it. So the explicit formula in this case would be starting points, which it began at 3 dots. You could say f of n is equal to 3 dots times a pattern of 2 to the x power. All right, so that's not the only way you could have written it. You could have written it using any starting point. You could have said 6, which is the first minute. You could have said that's the same thing as 6 times 2 to the x minus 1. And the reason why it's x minus 1 is because you're starting with the first minute. So as long as you make this number the same as the term of this number. All right, so in other words, the first minute had 6 dots, so I subtracted 1. But if I had used 12, which was 2 minutes, 12 here, then it would have been x minus 2 power. All right, so let's get to that homework. So the homework says you run a business making birdhouses. You spend $600 to start your business, and it costs you $5 to make each birdhouse. Total cost of building. So if you build one birdhouse, you spent $600 to start up, plus one birdhouse makes $605. And then 610, and then 615, and then 620. And you're noticing that the pattern here is an arithmetic sequence. It's arithmetic because you're adding 5 each time. So my explanation, I'm going to explain how I figured out the values I put into each cell. Basically, I started at $600 and I added $5 for each birdhouse. Explain how you figured out what this was cell number 8. So I could write a recursive or an explicit formula which would solve that. So I would write literally here, I added $5 after $600 for each birdhouse. That's literally what you would have written. You could also written the recursive, f sub 1 equals, or f, I always say it backwards, that's f of 1 is equal to 605, and then f sub, or function notation, f of n is equal to f of n minus 1, and plus $5 for each birdhouse. So that is how you find the next term, and if you want to find any term, you would simply start off with $600 plus $5 per birdhouse. So T was the amount of birdhouses. That's what I used right there. All right, so I'm going to eliminate that. Let's go to the next one. So you borrow $500 from relative and you pay them back $15 per month. So after 1 month, now you owe them $485 because you owed them $500 minus the $15 that you paid. And then $470, and then $455, and so forth. Keep subtracting 15. Well, actually, you're adding negative 15. Okay, so I would have said that. So I started with $500 and I subtracted 15 for each month I paid. All right, so then what are we talking about when we're talking about? So that would be f sub n is equal to f sub n minus 1 minus 15. That would be the rule for recursive. And the explicit would be $500 minus 15x. All right, number 9, you're saving for a bike and can save $10 per week. You already have $25 saved. All right, you're saving for a bike and can save $10 per week. So you start off with $25 to begin with, plus $10 more means you have now saved $35, then $45, and $55. All right, so the pattern is going to continue. So you start off with $25 and you added $10 per week. So that's going to be $25 plus $10 per week. So that would be the explicit. So y equals, or f of x. Depending if you want to write it in function notation or not. So this one's going to be recursive. You would be f sub 1 equals 35. And then f sub n is equal to f sub n minus 1 plus 10. And that's it. All right. Let me know if you have any questions. Thanks for watching.